class, and welcome again to Math Minutes. This is video 23, and we're going to start looking at slope of a line. So go ahead and get your notebooks out and turn to page 36. Slope. The slope is how steep a line is or how much it slants. This is our slope formula. When we've been given two coordinates, we can substitute these numbers into this formula right here and figure out what the slope of that line is. So from any two coordinates, we can determine the slope of a line by using the above formula. Substitute the x and y values for each coordinate and then simplify. Let's look at our example. We have a coordinate 6, 4, and we have a coordinate 5, 1. These are 2 points of a single line. Now, x sub 1, y sub 1, don't let that be too confusing for you. That's just telling you this is the x and y of the first coordinate. This is x and y of the second coordinate. It's not like an exponent, those little numbers that are above a value that, well, they're just not exponents. This is just telling us this is coordinate number 1 and this is coordinate number 2. So let's substitute those values in. If you look at our formula, it's the y from the first coordinate minus the y from the second coordinate. So our y from our first coordinate is 4. Our y from our second coordinate is 1. That's why we have 4 minus 1. We're subtracting those coordinate points. And then we look at our x's are underneath. Our x sub 1 means our x from our first coordinate, which is 6. That goes here. And then we're subtracting the x value from the second coordinate, which is 5, and that goes here. We simply have to subtract. 4 minus 1 is 3, and 6 minus 5 is 1. We simplify that, we get our slope of 3. So as long as you have two coordinates and you refer to this slope formula, you will be able to figure out the slope. And from that information, we'll be able to graph some lines. But let's first, before we do some practice finding slopes, let's turn to page 37 in your notebook. And let's just learn a few more facts about slope. If you see this page, we have 4 different examples of the way a line can slope. When a line looks like this, it is negative. Negative slopes always slope up to the left. This slope, this line, is going up and to the right. This is a positive slope. When we have a flat horizontal line like this one, always perfectly horizontal or flat is a 0 slope. A flat surface of any kind has no slope. If you stick a marble on it, it's not going to roll. It's not slanted. Perfectly flat. 0 slope. The opposite of that is a line that's straight up and down. Now, if you think about it, it also kind of is a 0 slope. It's not slanted. It's completely vertical. But that isn't 0. This is a term called undefined. Undefined is always perfectly vertical. And as we start working with linear equations more and graphing things, you'll see why. Undefined. Turn to your next page, 38, and let's just do some practicing, not even graphing. Let's just practice finding what the slope of a line would be that's connecting two given points. So let's refer again to our formula, which is y sub 1 minus y sub 2. All of that is being divided by x sub 1 minus x sub 2. So remember what those little sub numbers, it's not that confusing. Let's just say this is coordinate number 1 and that's coordinate number 2. So we're going to divide. We're going to take our y, which is 3, minus the y from our second coordinate, which is 4. Then we're going to do the same thing, but with our x's. 3 and 0 minus 0. What does this equal? 3 minus 4 is negative 1. We're taking away more than we started with. 3 minus 0 is 3, so our slope equals negative 1/3. Let's take a look at number 2. 2 coordinates. What are the y values? Negative 2 minus 1 over the x values. 4 minus 3. Negative 2 minus 1 is negative 3. 4 minus 3 is 1. Let's simplify that. We know that any number, any fraction that has a 1 as the denominator can just go away. It just means it becomes a whole number. So to simplify this, our slope would be negative 3. Number 3, let's look at our y values. 0 minus, and what's our other y value, is a negative number. This is another place where you may make what a common mistake is to just write a number 3 there because you see that the minus sign, but we are minusing a negative 3. We always have to remember to put the entire integer in here. So let's now look at our x values. 3 minus this 3. Oh my goodness, okay, this is looking a little messy maybe, but let's just apply some of our rules. This becomes 0. Do you remember what happens when we have a minusing a negative number? You can refer back to your chart on one of your first pages in your notebook. When you're minusing a negative, you're really moving to the right on a number line, which means we're really adding. So these two negatives become a plus 3. So 0 plus 3 is 3. And here we have 3 minus 3. That is 0. Now this is the first time we've come up with this. Does this fraction equal 0? It actually doesn't. It's actually undefined. It is impossible to divide 3 or any number by 0. This slope is undefined. This would be a case, if you go back to page 37, if we were to graph these coordinates, it would be a line looking straight up and down, undefined. Let's take a look at number 4. Let's look at our y values. 2 minus 6 and negative 5 minus negative 1. Here we ended up with those two negatives again, right? Well, let's look at what our numerator is first. 2 minus 6, the difference between 2 and 6 is 4, and we're taking away more than we started with, so we end up with negative 4. Now here, negative 5, what happens when we minus a negative again? It kind of, this is the way I remember it. If I have a minus a negative, I just connect them like that, and I make it a big plus. Negative 5 plus 1 gives me negative 4. What is our simplified slope? Well, 4 divided by 4. Do you remember any number that has the same, any fraction that has the same numerator as denominator equals 1? Now let's look, we've got some negative numbers here, so let's apply our division rule. We have a negative being divided by a negative. So if you need to refer to your chart from an earlier lesson in your notebook, when we divide a negative and a negative, when the signs are the same, it's positive. So our answer is 1. This has a slope of 1. Let's take a look at number 5. Let's take a look now at our first y value is 0. And we're going to minus the other y value, which is 4. Then we're going to take our x values. That's a 0. And we're going to minus it from this coordinate. X value is 3. Don't take a fast look and say, oh, it's 4/3. Well, it's 0 minus 4, which gives us a -4. 0 minus 3 gives us -3, and it actually does. We can't simplify this anymore other than making it positive. We're making it positive because a negative number is being divided by a negative number, so all that happens here is it becomes positive. So it is positive 4/3. Let's take a look at this one. Our first y value is 3 minus 3. -2 minus our second x value, which is 4. 3 minus 3 is 0. -2 minus 4. Now these aren't two negatives together. It's just a negative, and then you're minusing a positive 4. So we're going left. We're going further in the hole. So -2 minus 4 gives us a -6. And we can keep it written that way, or we can write the negative out here and make this 0 over 6. Now, this is different than undefined when 0 is in our denominator. This one, what does this simplify down to even again is, what does this equal? Well, it's 0. Any 0 divided by 6, it's going to go in 0 times. So anytime you have a numerator that's 0, your value is 0, and it's neither positive nor negative. What kind of slope is this going to look like? If you turn back to your previous page, we ended up with a 0 slope. If we were to graph this line, it would be lying flat somewhere on this grid, depending on what something else was. So there you go, 0. All right. That is how you find slope of a line when you've been given two coordinates. Be sure and bring your completed notebook to class to get full credit, and I will see you there.